The question asks us to find the total cases where a 5-digit integer is non-increasing. Let's write a 5-digit integer as a, b, c, d, e. To meet this condition, a must be greater than or equal to b, which is greater than or equal to c, which is greater than or equal to d, which is greater than or equal to e. Once the 5 digits are chosen, there's only one way of writing a non-increasing number. Let's take a case scenario. Imagine we have the integers 8, 2, 4, 1, and 5. 8 must go in the first spot, because if 8 isn't in the first spot, let's say another integer is there, for example 5, then 8 would be after 5, and this would violate the case where a has to be greater than b. Therefore, 8 must be in the first spot. Using the same logic, 5 follows on, and the rest of the number is completed. Repeats aren't an issue either, because we're only calculating the number of combinations, not permutations. So we can reframe the question as, how can we pick 5 different integers from 0 to 9 to make a 5-digit number where repetition is allowed? To use this, we can use stars and bars. Let's take boxes with each integer is assigned to a box from 0 to 9. Every time a ball is placed in a box, that means we must take one of that integer. For example, here, number 1 must appear once in this integer. An easier way to visualize this is by using barriers. Let's say with this gap, where between two boxes is a barrier. We have 9 barriers because there's 10 boxes. Drawing out these 9 barriers, we know that there are 10 different places where the balls can go. This makes for 15 different spots where the balls are able to be put, because there's repetition involved and there's no limit on the number of balls that can go per box. Using the principle of stars and bars, where there are n categories, in this case 10, and k selections, which is 5, we have n plus k minus 1, choose k. This can be rewritten as 14 factorial over 5 factorial, 9 factorial. We can simplify this as 14 times 13 times 12 times 11 times 10 over 120, which is also written as 2002. This seems like the final answer. However, we have one final step, because we have to check if all these integers are actually 5-digit numbers. Let's imagine that all 5 balls were placed in the 0 box. Then, this would not be a 5-digit integer, because 0, 0, 0 has a 0 at the start, and this means that it's smaller than 10,000, which is the smallest 5-digit integer. Therefore, this case is extraneous and invalid and has to be taken out of this total. However, there are no other cases where a number is smaller than a 5-digit integer. Therefore, we have a total number of cases of non-increasing integers, which are 5-digit numbers, as 2001.